Um, anyway, thank you all for coming. And without further ado, I'll introduce Scott and let him take it away.
Great, I'll get started. My name is Scott Jones, and I am working on my PhD at the University of Arizona. And I am also in Dr. Steve Archer's lab, where we look at all things related to shrub encroachment into rangelands, arid and semi-arid grasslands. My personal research is very focused on the long-term rates and dynamics of the encroachment process based on different soil and topography, as well as how that impacts valuable ecosystem services that people value and how people value those ecosystem services. So a lot of my research is focused in the Cienega Creek area at Las Cienegas National Conservation Area. So I'll touch on that just briefly. And yeah, so the overview of this, I was asked just to give a quick talk on the basics of shrub encroachment, the drivers behind it, how this impacts ecosystem function, ecosystem services, and then some management ways you can do that with a context in our own backyard. So over the past 100 to 150 years, we have seen a proliferation of unpalatable native woody plants into grasslands. So here's a photo from Santa Rita Experimental Range, which is just over the Santa Rita Mountains from the Cienega Creek region. And this photo is from 1902. I know in November you guys had a talk, Sheila gave a talk on repeat photography. So here's a good example of how it can be used. But you'll see this is at the top of Orphan Butte looking out, and you can see those black blobs are mesquite, and they're mostly contained into the channelways. So if we fast forward 60 years, outside of a road being added to this area, you can see that the shrubs have started to migrate out of those lowland areas and into the uplands. And then if you fast forward to 2018, you can see across the entire landscape that mesquite and other shrubs have become a dominant factor across the landscape. Now, this isn't only constrained to the Southwest, it is happening all over the United States, and it is also happening globally. So here's a picture of Eastern Cape and South Africa, and you can see from 1925 to 2011, shrubs have become a dominant feature on the landscape. Before I get started too, I think it's really important that I highlight that all of this, it's going to depend on things. This phenomenon is extremely complicated. It is dependent on a number of different factors. And just because something, an area encroached in one location, a very similar location may not ever see encroachment. But this whole process is dependent on a slew of how climate interactions, different geomorphology and topography, so soil, soil type, elevation, and then also what kind of disturbance regimens have been on this landscape, whether that be herbivory, decreases in fire. So I think we always joke about it in our lab group is you'll look at something and then it comes up of, well, yeah, but it just depends on what's going on. So I will constantly be saying that throughout the presentation. So rates and dynamics of the encroachment process. So what we know is that it's been extremely rapid. So over the past century, we've seen areas that have been mostly open of shrubs become almost closed woodlands in some location, and shrubs being a dominant factor on the landscape. This process is nonlinear, and it can be punctuated by either disturbance events, whether that be overgrazing or decreases in fire regimes, or climatic changes, changes in precipitation and prolonged drought. And then again, it really depends on this spatially heterogeneous of the landscape, whether what type of soil you're on, the topography of the location. And I often come back and think about this photo right here. It's an aerial photo looking out at the Santa Rita Mountains. And you can see on the left, you have a more sandy soil that is more suitable for shrubs. And then if you look right across on the left or the right-hand side, you see an older soil type that is higher in clay content, which is more resistant to shrub encroachment. And you can see the difference between those two sides. So very similar climate, precipitation regimens, but you have just these differences in soil, which is dictating where shrubs will encroach. So what's causing these shrubs to move into grasslands? What are the drivers behind it? Well, they're complex, as I mentioned, and they're very interconnected. And they can range from climate, grazing, fire, and there's some ideas that increases in carbon dioxide and nitrogen may actually play a role. But I believe in our region, we're really looking at climate, changes in grazing, and then in fire. So I'll cover those fairly quickly. So climate, where shrubs are located, where grasslands are located, is really dictated by precipitation of the region, the temperature of the region, which also impacts the potential evapotranspiration coming off of these, the vegetation. So this figure that I've added right here is from an African study, but it actually holds up extremely well for other grasslands globally, but it's showing what is the maximum potential shrub cover at a location based on its annual precipitation. And you can see as you increase up to about 500 to 650, you have this linear increase in the potential that shrubs, the amount of shrubs that can be on the landscape. And then it evens out once you get up to about 600, 650. But you may notice that there's a bunch of these dots, which represent different sites across Africa that haven't reached their maximum potential of shrub cover. And again, this is very dependent on the regimes that are going on there. You know, are they treating for shrubs there? What's the fire regimen like? You know, what's the soil type, topography? So again, it's very dependent. So in the Sonoita region, we are about 350 to 450 mean annual precipitation in millimeters. And that puts us right around 30 to 40% maximum shrub cover, theoretically, using this model. So what happens when you start to change the amount of precipitation you get in a location? Well, this is really dependent on the physiological differences between shrubs and grasses, especially in their rooting ability. So shrubs have a very extensive root system, especially in terms of their taproot, which they will put down. Sometimes in our case with velvet mesquite has one of the deepest taproots, can go down to 100, 150 feet to explore for water. Now, this is compared to grasses, which have a very intense root system that's located mostly 20 to 30 centimeters below the soil. And this is best suited to utilize resources in that top section, where shrubs, when they're young, will compete with these grasses until they can put down that taproot. And at that point, they usually have access to deeper water sources and other nutrients. So what happens if you start to change precipitation in an area? Well, if you already have, so if you increase precipitation, what you can see is enhancing woody plant establishment. So you have this competition when they're young between grasses and shrubs, but if you add more water to the system, that competition is decreased and it allows for shrubs to grow faster and increase in their density. Well, contrary to that, if you decrease precipitation, you also see an increase in shrubs, especially these larger ones that have deeper access to lower water resources. So they're more resistant to drought, and they will be able to access water when these grasses do not. And then if you start shifting precipitation between winter months to summer months, which is projected under our climate projections as we get warmer, you'll see longer times of drought, and then our precipitation will come in just large bursts in the summer. And that is projected to also favor woody plants over grasses. I like these photos that I included here. They really show these rooting systems of these shrubs. Here's a mesquite in Arizona. And you can see not only does it have extensive lateral rooting system, but it also has that deep taproot system. And then here is a photo from the chaparral in California, and you can see the root system of this plant just going very deep into the soil, accessing those deep water reservoirs. So what about grazing? Well, grazing also plays a role in this whole story. As people moved west, they brought along grazing traditions that were usually done in the Great Plains and the eastern United States that was more suitable for grazing large ungulates on the landscape. And it was seen at the time that this Western was just limitless and we could overexploit the resources. And then around the 1930s, we really started to see a crash in these systems. You saw decreases in grass. So that led to the passing of the 1934 Taylor Grazing Act, which started to set limits on the amount of cattle you could have on the landscape per area. But this whole thing with grazing is very complicated, as in some areas, grazing has been shown to actually increase grasses where these large ungulates have been traditionally on the landscape. Where if you get into the drier, arid, semi-arid regions, it can either not have an impact, or if you get into the real dry regions, you tend to see crashes in grasses, which allow shrubs to take over, leading to shrubs with large areas of bare ground in between them. On top of that, it is also a disturbance regimen. And if you're decreasing grasses, you're decreasing the amount of fuel load you have on the landscape. So you couple this with people moving into these areas, not wanting their house to burn, understandably, and you're putting in active fire management regimens. And what we've seen is we're decreasing the fire frequency, the intensity, so you don't have enough grass out there to carry fires long extents, and the intensity that you need to kill off some of these larger shrubs. So I remember when I first saw this photo in the Arizona Daily Star, right after the sawmill fire, and it was just very striking to me, as the only thing that burned out there was the grasses. Those shrubs looked pretty happy. They were outside of the flame zone, and I'm sure they're out there today still growing. So what does shrub encroachment look like in our own backyard? So as I mentioned, my research has focused on change in the Las Cienegas conservation area. And to do this, I have gone back and located the oldest imagery of the area, aerial imagery, which dates back to 1936. And from there, I took about every 20 years and found new aerial imagery and quantified the shrub on the landscape. So here we go. We can start at 1936 if you want to get oriented. Right here is about where Empire Ranch is. Some areas to really focus on is this little area down here, which is a clayey swale, and then the loamy uplands right here. So from 1936, we jump up to 1975, and you can see shrubs have really started to move away from those channels. And then 1996, you can see very much covering areas of those loamy uplands, and you can see the first signs right here of picking up on the imagery of brush management actions in that loamy uplands. Jump to 2007, and then all the way up to 2017. So again, focusing on those areas, you can see large areas of brush management that have occurred across the landscape. And then also, you've seen areas that have just completely been converted into almost closed canopy shrublands. But if you really look down into the fine details of this, it's really interesting that some areas seem to have been really encroached while other areas haven't, especially in this little area right here. You have little tendrils going out that just seem to be resistant to shrub encroachment. And this is actually highlighted in the entire southern half of Cienegas, which has been very resistant to shrub encroachment and has seen very little change. So what I did with my research is I decided to break down these areas based on ecological site, which is heavily dependent on the soil type that's underlying these areas. So here's a map of what it looks like. I apologize if anyone viewing this is colorblind. I realize after I put it together, it's probably just looks all the same color to colorblind folk. But you can see here the differences. So the southern half is this loamy upland limey slopes, which seems to be pretty resistant to encroachment. But what are some, so let's look at how shrub encroachment has changed across these different eco sites. So here you have the diamonds representing the 95th percentile of growth, meaning this is what we're considering the upper limit that these sites will most likely reach. And you can see there's a vast difference among the potential shrub cover on these sites compared to just based on their eco site. So you have areas like these loamy bottoms or these clayey swales that can support up to theoretically up to 40% while areas like your loamy upland limey slopes are constrained to about 5% coverage. So I also wanted to look at, so if you go back to this image, you really notice the southern half has very little shrub on it. So one of the things that pops up is this is an elevation difference. So as you go south on the reserve, the conservation area, elevation increases. So I also looked at topography here, and that black line right there is representing that 95%, theoretical maximum shrub cover here. And you can see as you increase elevation, you're seeing a dramatic drop in the amount of shrub cover that area can support. I didn't include this for the talk based on the brevity of it, but I've broken this down into the different eco sites, and it is very interesting to see that your loamy uplands tend to be really even up to about 500 or 1500 elevation, and then you see the drop off there, while the loamy bottoms follow this figure right here very similarly. So I've done this for a number of different variables, including slope aspect, slope inclination, the amount of water that pools per area, and then also the amount of clay in the top 0 to 10 centimeters of the soil. Again, I haven't included those, but I have those if anyone would like to see them. I can either send them to you, or we're hopefully having this, we're writing it up for publication at the moment. Great. So why should we really care about shrubs moving into grasslands? Well, we had this traditional view on things that was very focused on either livestock production, changes in hydrology, so the amount of stream flow you had, or groundwater recharge, and then also wildlife, with mostly focusing on game management. So these were all things that people were very concerned about at the turn of the century, changing. And from there, starting about the 1930s, we implemented a suite of different management solutions that we call brush management. If you've ever been driving through Las Cienegas, no doubt you've seen giant piles of mesquite piled up. And this is a form of mechanical grubbing. So what they're doing is they're going out with backhoes. This middle image right here is showing this. And they're just grubbing them out of the ground like that. And then they pile them up and eventually hopefully burn them, or just let them break down naturally. But you can also do this through chemical means, through aerial applications of herbicide, or on the ground. If they're small enough shrubs, you can spray them, spot spray them with a backpack sprayer, or you can also implement prescribed burning. So let's look at how these management solutions of brush management have impacted forage production. And I need to mention that these management solutions, when they were first implemented, were seen kind of as like, you treat this area and you fixed it. And we're really noticing at this point that is not the case. Shrubs will re-encroach back into these areas. These processes, or these management solutions, are also extremely expensive and can range up to, say, $500 an acre if it's a really heavily thicketed landscape. And the results you get from it may be very short-lived, upwards to 5 to 7 years before you have to go back in and retreat. So last week, or actually 2 days ago, I was just out at Buenos Aires National Conservation or Wildlife Refuge in the Altar Valley. And this picture I took was almost 1 year exactly from when I was last out there, and they had just finished up a large mastication brush management process where they took this big machine right here. They lifted its big front part over the shrubs, brought them down, and then they masticated them all the way down to stump level. And you go out there and you look, and it was just almost completely clear, open grassland. Well, I was out there 2 days ago, almost a year later, and this is what the site looks like. You can see that those shrubs have started to resprout back up. And if you don't take care of these or go back in with a retreatment in the next 2 years, everything you've done may be for nothing. So again, let's look at this in terms of forage production. What are your long-term results of going in and treating? So here's a figure right here that's looking at herbaceous biomass change after a brush management event. And what you see is On the bottom, on the x-axis, you see the number of years following that. And up to the first 5 years, you see an increase in the amount of herbaceous biomass you have. But then at 6 or 7 years, you see a crash back down to almost what you started with. And this is presumably because the shrubs have started to re-encroach back into the area. As Tom mentioned, part of my research is focusing on human perceptions of these actions. And one of the persons I've talked to that has been involved in brush management actions so that we need to open our view of these to not just look at them as single treatments, but we need to look at them as more of a prescription for the landscape with repeated doses. So moving away from these traditional perspectives of why we should care about shrub encroachment is we've started to really frame this idea in terms of an ecosystem service perspective. So if you're unaware of ecosystem services, this is the term meaning the benefits that people or society obtains from ecosystems. So this could be clean drinking water, this could be forage production for cattle, that's a free resource you're getting from the ecosystem, or you can have things like biodiversity for ecotourism, or just the value of having high biodiversity or animals existing is important to a lot of people. So we've started to frame it moving away from just this traditional view of forage production, water, and game species to open it up to a larger suite of things that can be impacted. So let's take a look at 3 of these. We'll look at primary production, carbon sequestration, and biodiversity. Great. So here's an image here that's looking at changes in above ground net primary productivity as shrubs increase. And you can see at these lower mean annual precipitation areas at the tail end on the left side, as shrubs increase on the landscape, you see a decrease in the amount of annual net primary productivity you're getting from that area. But as you increase annual precipitation, you're seeing increases. As shrubs move into the landscape, you're seeing increases in annual net primary productivity. What's interesting about this figure is if you compare it back to the original figure I showed of mean annual precipitation, that leveled off at about 500–600 millimeters. And this one you see continuing to increase as you increase mean annual precipitation with shrub encroachment. And the idea of this is that the architecture of shrubs are able to utilize greater areas compared to grasses. Right, so let's look at below ground soil carbon. So in drylands and grasslands, most of the carbon is actually stored below ground. And if you look at this for a climate change perspective, storing carbon, and then also on a net primary productivity, actually having that carbon in a usable location is very important. So you look at how shrub cover has impacted the amount of soil organic carbon on the landscape. And you see it's kind of a shotgun image on this graph, meaning that there really is no relationship that we can see at the moment based on the amount of carbon that's stored underground based on shrub encroachment moving in. And I think what's important about this though is where the carbon is being stored. So if you remember back to those pictures of the roots, shrubs are translocating some of this carbon and putting it very, 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 very deep into the soil. And that carbon then becomes unusable by the grasses in that top 20 to 30 centimeter range. So we can move on to biodiversity. And as I mentioned, having biodiversity is very important to a lot of people, whether that be for economic reasons of ecotourism or hunting, or just people enjoy having a diverse ecosystem and value species being there. So if you look at this figure on the right, it's very interesting that actually you find as woody plants encroach into grasslands, you actually see the species richness increase. And the idea behind this is that you're opening up new ecosystems or new niches for species to utilize. But this might be a really narrow view in the fact that what we are also finding is some of these grassland obligates that evolved to be specialized in this grassland ecosystem is that they're suffering. So you may see increases in species richness, but this is coming at the cost of these grassland obligates, whether that be large grazers like pronghorns that will actively avoid heavily shrubbed areas because they don't like to not be able to see around them, to rodents like the black-tailed prairie dog. If you ever go out and check out the reintroduction process or project in Las Cienegas, you'll notice that they actively remove shrubs from around their location due to those being nesting habitats for raptors and making it easier for them to be picked off. To these grassland obligate birds like the Botterize sparrow here. And then I think we also need to look at it too is what about ecosystem biodiversity? These savannas and grasslands have been characterized as one of the most endangered ecosystems in North America. So to me, I think it's very important too of protecting these endangered ecosystems. So let's focus in on birds because there's been a lot of studies. I think Eric Anderson presented on this 2 years ago at the Science on the Sonoyta Plain. So I'll give you some examples from his paper he published with Bob Steidel in 2019. So again, here's a look at the effects of woody cover on species richness of birds. And he looked at Las Cienegas, Appleton White Research Ranch, and then Jornada Experimental Range in New Mexico. And he found similar things. As you increase cover, you increase the species richness of birds. But if you look out from this and look at the type of birds that are occupying this area, you get a much more interesting story as you see these grassland obligates that are on the left over here. You see a deep decline in their breeding population as you increase shrub cover. And I also like the bottom left one there is a mourning dove, and they look like they can just basically live anywhere. I've seen them nest in just the worst locations, empty shoes, buckets, so they don't really care. They just utilize wherever they're at. Why that image didn't show up. Sorry, there was supposed to be an image of a transition there. But what about herbaceous biodiversity? Well, there was a review across North America that looked at 29 different sites, and they showed as shrub encroachment increases, you have a dramatic decline in the amount of species richness you have herbaceously. So there's two images here, there's two figures here. The top one is juniper moving into a tall grass prairie. And then the bottom one is creosote moving into a grama grassland. And you know, this has very important impacts on the structure of the ecosystem, especially for things like arthropods that don't have large ranges and that are usually specialized to specific plants or small areas of an ecosystem. They have small niches. And if you eliminate those from it, you eliminate a giant food source for a lot of these birds or other organisms. So what it was found is across these 29 studies, you saw a species richness decrease of about 45% on average of herbaceous biodiversity. So kind of summing stuff up, this whole process, this whole phenomenon is very complicated. But if we can better understand the rates and dynamics of the encroachment process, and then couple that with an idea of what we expect to come from treating these areas in terms of ecosystem services, you can better employ, you know, where, when, and how often to use these brush management actions to achieve conservation objectives. But I think this is a pretty narrow view in a way, because I think you're completely missing a social component to this. In the fact that, like, what ecosystem services do people demand highest? So in other words, what do you and me or the other people of Cienega Creek watershed or the Cienega watershed, what ecosystem services do they want from this grassland? Because ultimately we're the ones choosing where to treat, how often to treat. So if one thing is very important, we could funnel all of our resources into that area and most likely protect that service in that small location. So understanding what people actually want from the landscape on top of these things can actually truly give you proper management of those areas. And before I close out, I'll be a little selfish and self-promote this study I'm doing right now to actually address this issue that Larry Fisher and I are working on in trying to capture the social perceptions of semi-arid grasslands and the societal benefits that they provide. So we're doing this through an online survey that we've created. I'll link the survey in the chat as soon as I close out of this presentation view. But we're asking people to view a number of different images and then provide their perception on how they feel like these landscapes are at providing these benefits or these services. And then on top of that, we're also asking people to rank these really important ecosystem services against each other. So I know some of you have already taken the survey, and I appreciate that. Thank you very much. If you haven't, please consider participating. I would really appreciate capturing a full breadth of people's perceptions in this location. So with that, I'm right at 30 minutes and I'll close out, and I will take questions right now if anyone has them. Thanks for letting me present on this. I'm excited to hear what people have their thoughts on it.
Thanks, Scott. Are there any questions from folks? Feel free to use the chat or break in. I was curious about the soil fertility interactions, in part because when I was at Riverside, I did some work in Southern California. They actually have some of the reverse problem. Mediterranean grasslands have replaced coastal sage scrub, so the shrub environment.
Yeah.
And there, the very high nitrogen deposition in the LA Metro seems to have encouraged that grass invasion. Mm-hmm. What's the theory on shrub encroachment and sort of end deposition, end fertilization, and what that interaction looks like?
A bit out of my GIS perception, but I know there is this idea that depending on the type of climate or the climate you're in, if you're in these hyper-arid regions or these arid regions, it's going to lead to desertification. But if you're in these humid regions, which it sounds like you're referring to, yeah, you see a difference of, you knock down these large trees or, whatever else on the landscape, and you almost turn it back into like a woodland or a savanna. Okay. Okay. I see that Julia Fonseca has her hand up. So go ahead and.
Hi. Hey, yes. Julia. So my question was getting back to the limey slopes versus elevation. So yeah. I thought I heard you say limey slopes were and limey ecological sites in general looked like they were more resistant to the shrub invasion. But then you talked about the elevation, and so are you saying that it was really the elevation and not the ecosite, or it was both, or can you decompose that into percentages? Can you clarify?
Yeah, I think looking at that, I showed that to just kind of show the complexity of this issue of I broke in the chapter we're working on. I've broken down these this elevation thing by differences, by these ecosites individually. And the one I was talking about was the loamy upland limey slope, which is that southern half of Las Cienegas. Let me see, I might have. One sec. Yeah. I'll reshare as soon as I. All right, reshare my screen. So here's it broken down by the different ecological sites. And you can see the differences here, but I think it really highlights.
I can't see it.
Oh, you can't see it? Shoot.
I can't.
Oh, there we go. Is that showing up?
Yeah.
So these are the 6 major ecosites out there that they account for about 98% of the area at Las Cienegas. So one you're talking about would be the bottom right, which is the loamy up and limey slope. So I really showed it to just kind of show this like interaction that you know, it really does depend on a number of different topoedaphic variables that will dictate where they'll encroach based on these ecosites. So you have a number of areas on that far left that haven't reached this theoretical maximum cover, and that may be constrained then by, say, the percent of clay in the top of the soil, or the depth to bedrock, or the amount of water that's captured in those locations. So does that start to address what you were getting at?
Yes, thank you.
Oh, Larry's got his hand up.
Hey, Larry.
Hi, Scott. Great presentation. Glad to see it all coming together. That's the first time I've really seen it in one presentation. So really commend you for it's very, very comprehensive and interesting. You know, toward the end of your talk, you mentioned that we, the people, kind of make these decisions. They're made on the basis of ecosystem service, but that's really not the case. We know that BLM is going through their EA, and you know, they're going to be making decisions based on their expertise, and you know, and certainly some public input. Some of it may be contentious, some of it may be clear to them, but I just wondered, you know, because your study is so timely and the EA is being written as we speak, I wondered what your observations of their decision process. Are they using, you know, ecosites? Are they using some of these edaphic and climate considerations, or are they managing for, you know, I mean, what are the ecosystem services they're managing? How do they merge, you know, kind of the natural kind of considerations with the services, the ecosystem services aspects?
Yeah, thanks, Larry. I'll try to go back to this image of where shrub cover is on the landscape. I think this should be the right one. I have to go through to 2017, but you can see where these brush management actions have occurred, mostly on the loamy upland, tend to be in areas that are highly visible, as that road runs right through near the Empire. And a lot of the consideration seems to be just areas that may be utilized or be pronghorn habitat that tends to have a pretty strong voice in the area, or just areas that look like they're heavily shrubbed and they want to knock them back. I don't know how much consideration is really being taken to these different topoedaphic variables, or just the natural history of the area, if those areas were shrub, had high covers of shrub, you know, at the turn of the century or not. Dan Quintana shared with me a number of areas that they're thinking about treating. This was before COVID. I don't know if they've undertaken it or not. But some of the areas are in locations that have had traditionally high levels of shrub. So you think about that, going and treating, you're going to have to change your management objectives at that point based on how fast those shrubs will most likely re-encroach into that area. So where you might be able to get by with 10 to 20 years in some of these locations in the loamy uplands, if you're treating in a loamy bottom or a clayey swale, you may have to be in there next 2 to 3 years.
Yeah, it struck me, Scott, that soil texture aspect sort of speaks to, I mean, I think strategies to work on removal and, right?
Yeah.
Areas where it's a little more resistant might be areas where you want to focus your restoration effort to some degree, because you might be more successful. Maybe those are places where more frequent prescribed fire or other strategies might end up being more successful, as opposed to these very, you know, the sandy soils where it's like you're going to be fighting a battle forever. So.
Yeah, I mean, if you wanted to put the resources in, you could probably keep it, but
right,
extremely expensive. And I know, Gita, you just popped on there. We've had this conversation a number of times at the bioplanning meeting of, you know, should we be looking at this differently? Of, you know, you have this southern half that's higher elevation. We've had conversations that potentially this may be because the temperature is a little bit cooler up there.
Yeah.
So do you take that resources and just triple the amount of land you can cover and really focus on keeping that area clear? And especially in light of climate change, you know, if those areas become warmer, you would expect them to begin to see erosive encroachment.
Yeah, I was shocked a couple of years ago. I went out to the Walnut Gulch Experimental Watershed with ARS folks, and Dave Grosch was like, "Yeah, we don't have any mesquite up this high." And I'm like, "What do you mean this high?" He's like, "Oh, they have a cold tolerance." And I'm like, "Oh, well, of course they do. I mean, most species will have a limit one way or another, some climate factor that limits their spread." But yeah, that southern half, right, the cold, and it's also the nature of it is likely to trap cold air, and that may kill, you know, a good hard freeze may kill the small seedlings there.
Yeah.
But exactly, like if you deploy resources down there, you can essentially completely extirpate mesquite, and prevent it from easily encroaching again. Not that, I mean, mesquite pods will travel.
Yeah.
So
those are really good dispersal agents.
yeah. I mean, whether it's a pronghorn or a cow, it's going to move around. So
yeah, and I that comes back to touching on this idea of, you know, what we want from the landscape. If people are really interested in maintaining a wide open, you know, highly appealing, highly aesthetic, large viewshed of a grassland, maybe you do focus all of your resources on that southern half. But if you're really interested in, you know, game species or other things, maybe you create different corridors based on the types of treatment you do.
Yeah.
But it's not just, I think what Larry was touching at is, it seems that we've been using this idea of just seeing an area, it's heavily encroached, people may be out there, let's just cut it all down.
Yeah.
Well, not exactly.
Well, yeah, sorry, I'm very.
I think it would be a really, first of all, I think this really needs to be discussed in biological planning.
Yeah.
I think it would be very interesting because these decisions, with a great deal of public input over 7 years, are in the RMP, in which it says, here's how the desired and future conditions and what it is we're going to do treatment wise, fire, mechanical, and so forth. So what would be really interesting is to look at those decisions that were made with information and input at that time, okay, a long time ago, compare it with new additional information, and how should these decisions be tweaked? That's supposed to be part of the plan evaluation, which has been totally set aside for the last couple of years. I don't know where we're going on it, but it would be very interesting because you have to have a basis for tweaking things. It didn't work, there's no money, but look, this is more science-based tweaking.
Yeah.
So I really think that would be something we need to really think about with regard to where did management think it was going and the public bought off on it, and where maybe new information might be that says, have you considered this?
Yeah. And yeah, sorry, Sheila, I was generalizing very, very heavily there with just, you know, picking this area, but I have noticed on some of the proposed planned treatment areas, I mean, down in this area right there, there is actually an idea to treat in that area. And I can tell you right now, that is, you're going to have to be back in there in the next 5 years at the latest to re-spot spray. So I don't know if that's an area that would be beneficial. Or do you focus maybe on a different location? Again, it's all up to what we want from this landscape.
Yeah, and I think Gita, I assume Gita has something to say.
I usually have something to say. I'm usually thinking about 10 different things at once. Yeah, it is a really interesting potential switch in how we approach conservation. You know, a lot of the focus in the past had been to look at places that are on the verge of a transformation that you can't, that's hard to get back from. So a lot of the emphasis was look for places where you're about to go over that sort of go from shrub encroachment to shrub conversion, and pull them back from the brink before they go over the brink. And now, as we're looking at these maps and the reality on the ground, and climate change, many of us, not all of us, really are starting to think more in terms of where can we succeed with moderate amounts of efforts. Where can we succeed at keeping things that are in open condition, keeping them open? And it's it's a fundamental shift in view that considers that the world around us is changing, and many of these things are many, but not all of these things are outside of our control.
As soon as we figure it out, things may change and have us adapt, which I think really highlights the beneficial nature of doing that collaborative conservation that Sheila brought up. Being able to adapt on the fly.
Yeah. I would love to see, I don't know if anybody's here is going to volunteer to do it. I've been wanting to see for a while an analysis that takes the bird data from Eric Anderson's work that you showed, and looks at the different guilds, the ones that are real obligate grassland guys and the ones that tolerate a mixed amount of shrubs, and then the shrubby guys, and look at over the landscape and say, well, how much territory does each of those birds or each of those guilds have available? How much of this landscape that you see in the map meets the needs of each of those species? And then look from there at, well, if we wanted to keep them all on the landscape, what would we need to do?
Yeah, I think it would also be interesting too to use some of these older imagery to track where their traditional ranges may have been. I mean, you're doing a lot of assumptions based on you don't know what the seed source was out there for food, but I think you get a general idea of this is potential habitat for them.
Mm-hmm. Yeah.
I sure don't want to start the resource land management plan over again, but I think it's real interesting that we could approach our biological planning a little bit different this year. Maybe not 4 technical teams that give 4 reports, but hey, this is let's really look at this harder and more intensely. And the fall is when we do upland, isn't it? The fall, upland, and larger landscape. So anyway, yeah.
So another question.
According to FLIPMA, the resource management plan has to be revised every 15 to 20 years. And, we're already 20 years in. So, I mean, it seems in hindsight that is a pretty wise part of the Organic Act for BLM is to revise those things periodically, and particularly with climate change and the shrub encroachment that we just heard about and seen. I mean, it is time to
Well, CWP presented BLM with all the tabled information and recommendation that came out of those workshops that we did, State of the Watershed / BLM workshops, almost 3 years ago, and we haven't heard back. So that might be a good place to look and see, well, what did we actually recommend to BLM do at that time? And maybe we didn't get this deep, maybe we didn't get this detail, but we're just stalled, Larry, and you're absolutely correct on what is required.
I think Julia had another question.
Yeah, going back to your methods, I'm sorry, I tuned in late and you probably
you're fine.
But what was the method for doing the shrub analysis for the older, particularly 1936 and other unrectified type photography?
Yeah, so I got originally got the Fairchild imagery from the Nature Conservancy, and then I tracked it down again at it's housed, I believe, at ASU, the original versions of it. And then using kind of some compare and contrast of like different resolutions, I mosaicked it. And then I had to eliminate quite a few areas that were heavily shadowed that you couldn't really tell what was on there. I also eliminated all the areas that were treated in the future, as well as along what we considered to capture most of the bosques. And then from there, we classified shrub. And in order to deal with issues of shadowing, because you see these blobs, you don't really know how much of that is directly looking down or how much shadow is going off that, we upscaled everything to 100 meters. Mm-hmm. So therefore, we figured that would capture, it's been done in the literature before, that would capture this error, minimize some of the error we're getting. And then from there, we threw all of these points together. There was, I think, 66,000 100 by 100 meter points. And then we plotted them on there based on, with the idea of over 100 years, these sites most likely would have a chance to reach that maximum cover potential. And then we could look at, why are some of these not reaching that? Why are others reaching that or shooting above it.
Okay, thank you.
Yeah.
Cool.
So Scott, I have another question, and I expect Roy and Laura may have thoughts on this as well. It was about how you, in the analysis that you just talked about, how you decided which areas to consider as sort of riparian communities instead of the upland communities, where, you know, on this map it would be instead of shrub cover, it would be tree cover, woody tree, riparian tree cover. Yeah. It's been a challenge for a long time figuring out where to draw the line between the shrubby grasslands and the stream and riparian systems that run through them. How did you guys approach it? How did you approach it in this?
We looked originally, I looked at some of the stuff Roy was doing and mimicked some of it because I had the object height models and looking at what areas were greenest over time to assume those were bosques, and then reading some of the literature, seeing how far out they could travel. We ended up just putting a buffer like 100 meters out on either side. And then we analyzed that, and it seemed to capture most of what that bosque area was. It's a very kind of crude, but it seemed to match what we were trying to do. And then in some of the smaller ones, smaller channels, we put 50 meter on either side buffers. So again, then when you upscale everything, you know, if you did have some of that kind of issues, it worked itself out. But, you know, if you're looking at this image right now, that large area that's almost white through there was all masked out of the analysis, assuming that's, you know, your bosque, your willows, your cottonwoods. But interesting too, those areas have also seen increases quite a bit, which is seen in the old historical imagery that Sheila showed in November. You can actually see that those areas along Cienega Creek just increased massively.
Yeah. Well, in a lot of places where we have cienegas in Arizona, I mean, the San Pedro River, most prominent among them, used to be a grassy cienega. It's a riparian woodland now. And there's discussion about what exactly changed, but it's a variety of things. Grazing history, actually probably drying, right? If you lower the water table, areas that were grassy wetlands turn into forests. So,
yeah, it's very complicated.
Yeah. No,
if you want to sit down and have a beer every once in a while, you know.
Yeah, maybe we'll get back to that soon.
Yeah.
I love hearing though that some of the stuff that's really complicated can actually that something as simple as 100 meter buffer around the streamline can actually cover most of it. That it can be adequate for some purposes. That's kind of great.
Yeah, I did have some overhead too, is when I plotted these in R, you know, some of these things were up to almost 90% coverage. And I was able to go back into the GIS layers, look at it, and then realize, okay, that should have been masked out. And then I could eliminate those from analysis.
Yeah, neat. Well, especially if your theoretical maximum is 30 to 40% and you've got stuff that's 90, it's a pretty good guess that that it's different. Yeah.
But then again, I mean, that just may be these bosques reaching out into these upland areas so that were traditionally mostly clear. You know, now you're seeing them heavily covered.
Hey, this is Laura Norman. Thank you. I logged in late and missed the first part, but what you're doing is really great and exciting stuff, and I'm happy to learn about it. And I was wondering, do you have any publications or documents that you could share that describe like this? Is this part of your thesis? Or?
Yeah, it's part of my dissertation. Well, okay. We have most of this written up and we're hoping to submit soon. So as soon as I have something and, you know, knock on wood, it's accepted, I'll be happy to share either with you personally or through the partnership.
Cool. Yeah, it looks like you're doing a lot of awesome remote sensing analysis that I know a lot of people in my group would be interested to learn about.
Yeah, there is a paper by Wen Ji in Jornada, I think it came out 2019, 2020, that does very similar methodology, only they only constrained it to just 2019 for their nape imagery.
Nice. Have you seen the work that Natalie Wilson did with describing the Cienegas in this area?
No, I haven't.
Okay, I'll send that to the chat here because it might be useful for you to overlay at some point. And also the one that Gita referenced that Roy had done describing riparian zones. And Roy has put it in here to marry it, but the idea to merge the different data sets and findings using different indices depending on what vegetation types you're trying to tease out might be, might be cool.
I'd be more than happy to share you know, in the very near future, some of these layers of classification and stuff. So, I mean, it took a very long time to compile stuff and tediously look at areas that were overclassified and go in and, you know, individually classify small little areas. So I would love to be able to share that with people to be utilized.
Nice. Well, thank you.
Yeah, thanks.
Well, let's thanks Scott again for at the end of our hour. Thanks, Scott. And as before, right, the recording will be up for this. I'm still looking for a speaker for May. I may have lassoed one, but we'll see. And look for that announcement. So thank you all for coming, and see you next month.